Hello everyone, here's a video on chemical reactions, balancing equations, and predicting products of those chemical reactions. So when we have chemical reactions, we have what you see in front of you, reactants in red and products in blue. So reactants react together to give you products. Again, chemical reaction takes what you have, breaks it apart and rearranges it into something different. You still have the original pieces, they just become something different, okay? Or they have a different combination in the end. So you'll notice that the sodium is still here. As a matter of fact, there's actually two sodiums here, and there's two chlorines here. It's a little bit of a different number, but we'll get to that in a second. And there's also, and there's two chlorines here, there's two chlorines here. Okay, so not only is there parts broken apart, rearranged into something new that still contain the old pieces, but also the count, the number of them are still the same. Okay, in order to do this, we're going to hold on. In order to preserve the count, we're going to do something called balance equations. And balancing equations preserves the law of conservation of mass and matter, at least matter. In other words, what you start with is what you have to end with, not only the mass, but also the kind and number of things. So for example, if you notice, these are called subscripts, and then I'm going to put numbers in front here, which are called coefficients. Okay. Now, I won't ever put those lines again, but just understand that the little numbers are called subscripts. I think we already talked about that with writing formulas. And the numbers with the lines here, here, and here are called coefficients. You can use any whole number you want at this point in time, any whole number you want to get the things to balance. And where are you balancing? You're balancing the reactants and the products. Okay? So you'll notice that I have two, let me erase some of this stuff here. You'll notice that I have two hydrogens here, right here, and two hydrogens here. We would say that those are balanced, okay? But you'll notice that here, there are two oxygens, but there's only one oxygen here, so those are not balanced. So the only thing you can do is put a number in front called a coefficient. That says that I don't have two, it says that I have two H2Os. So yes, it doubled the oxygen, so now there's two oxygens here to balance out these two oxygens here. So it's balanced, okay? But you'll notice that something else happened too. I had two hydrogens before, but now with putting the two in front, it now multiplies it by 2. So there's actually 4 hydrogens on this side. So let's put another coefficient here, and we end up with 2 hydrogen molecules on the left side. So your coefficients are really 2, 1, 2. You wouldn't write the one it's understood. Okay? Let's try the next one. Okay? So here, again, this is a trial and error type of thing. First tip I have for you guys is save oxygen and hydrogen for last. Okay? The second tip I have for you, so if you're writing them down, the second tip is if anything's alone like this one, especially oxygen, save that for last. Okay? All right, so let's go here. Let's use any non-hydrogen and non-carbon and balance it. So here's a carbon, those are balanced, okay? Hydrogens, I have 4 here, I have 2 here, so I better put a 2 in front. Again, you can only use coefficients. You cannot change subscripts, okay? And you can only put numbers in front, called coefficients, okay? So that balances out my hydrogens with my hydrogens. And now, oh, check this out. How many oxygens do you have here? Hopefully you're thinking that there are 2 oxygens here, plus another 2 here, because I put the 2 in front there. So it doubles everything. Whenever you put a coefficient of 2 in front, it doubles everything. If you put a coefficient of 3 in front, it triples everything. So now there's 2 here. So there's a total of 4 hydrogens on the product side. Well, there's 4 hydrogens here, so that worked out beautifully. Excuse me. I was using oxygen. Sorry about that. So again, 4 oxygens. Ignore what I said there. But I only have 2 oxygens here. So what do I need to do? If I double this, 2 times 2, or 2 plus 2 is 4, and the equation is balanced. And let me just clean it up so you guys have a final answer. The equation is balanced like that. Okay? Sorry about for the little whoopsie there. Let's move down to this bottom one, or at least the N2 plus H2. Okay? Again, pause the video anytime you need to. You'll notice that there are 2 nitrogens here, but only 1, so let's put a 2 in front. Okay? Again, only adding coefficients. Well, that gives us how many hydrogens here? If you're thinking 6 hydrogens, you're correct. There's only 2 here, so I need 6. So I better put a 3 in front. So just to erase all the extraneous stuff, that's the final answer. Al plus HCl, let's try that one. Again, pause the video if you want to work ahead without my help. Al is alone, so let's kind of save that for last. Okay. You can start now with it. It is balanced, actually, if you're taking a look at that. Let's start with Cl. Again, any non-hydrogen, excuse me, non-oxygen. So Cl, there's 3 here, so I need to put a 3 in front. Okay. Now, here's a problem. I have a 3 here of hydrogens and 2 here, so I need to change that. If I put a 3 in front there, that makes that 6. Okay, 6 hydrogens. Well, yeah, that didn't work out. But let me stick with this 3 here. I want to keep that 3. So that's 6 hydrogens. So what number has to go where I just erased? You better put a 6 here to balance out the hydrogens. Okay? Well, that just screwed everything up. Okay? Because now I have 3 chlorines, but all I got to do is put a 2 in front. Now I have 6 chlorines. Okay? Because again, you doubled the AlCl3s. So that 2 washes over everything. It multiplies everything by 2. And I think we're pretty good here, except for aluminums, right? And I have 2 aluminums and done. Okay? By the way, the coefficients have to be the lowest whole number ratio. 2, 6, 2, 3 are the ratios in this one. 2, 6, 2, 3. You can't get those any lower. Okay? If it was perhaps 4, 12, 4, 6, that's not really the correct. They're all divisible by 2, which gives you these answers here. Okay? So you want the lowest whole number ratio. Even though 4, 12, 4, 6 works, it's not the lowest. Okay? Let's try another one. Okay, now next we can balance out polyatomic ions as a whole. Okay? So if we take a look at this, let's start with the aluminum. Aluminum, those are balanced. Magnesium, magnesium, balanced. However, if we go one step further, you'll notice that the nitrate, there's 3 of them. There's 3 nitrates. There's 2 nitrates. 3 and 2, the best answer is 6. Let's put a 2 in front here and a 3 in front here. Now that doubles everything. That triples everything. Okay? All right, so how many nitrates do I have? 2 times 3 is 6 nitrates. How many nitrates do I have here? 3 times 2 is 6. Okay? Now, how many aluminums? Let me clean this up a little bit because I'm scribbling all over the place. How many aluminums do I have on the left? You have 2. Let's put a 2 in front here. How many magnesiums here? You have 3. You put 3 in front of here. It actually ends up being balanced. Now check this out. How many hydroxides are there? Hopefully you're thinking 6. There were 2, but you tripled it. How many hydroxides over here? Hopefully you're thinking 6. There were 3, but you doubled it. Everything is balanced in this equation. Okay? So that's balancing equations. Now, let's move on to a different topic called predicting products. Now, again, be careful with diatomic molecules. Hydrogen, bromine, oxygen, nitrogen, chlorine, iodine, and fluorine can never be written alone. They must be written with a 2. Okay, you must have a 2. These are 2 more ways to represent Hofbrinkel or Brinkelhoff. It doesn't matter. That's actually Brinkelhoff. Sorry about that. Anyway, so now if I give you a reaction, you need to be able to write it and balance it. Okay, so let's do just this first one, and then you can try the other ones a little bit later. So sodium metal. Now sodium is not part of Professor H. Broncliffe, so just write sodium. Reacts with potassium nitrate. So now I'm playing off of your ion sheets. You need to write potassium nitrate correctly. So with potassium ion, you look it up as K+. Nitrate's NO3 minus, so that's 1 to 1, so that's just KNO3. Notice how I had to consider that equation all by itself. Whoopsie. I had to consider that reaction, excuse me, that substance all by itself with the ions. That's going to produce sodium nitrate. So again, now sodium nitrate. Sodium nitrate. Okay, I looked those up on the ion sheets real quick. That's NaNO3 and plus potassium. Potassium metal is not part of Professor H. Broncliffe, so you're just going to put potassium. Okay? Let's make sure it's balanced. I have 1 of these. That's good. I have 1 of these. That's good. I have 1 nitrate, and I have 1 nitrate. This is balanced as it's written. Okay? All right, so again, when you're going through these, make sure that if you could try the next one, I'll actually give you the answer real quick. Unbalanced, but I'll give you the answer. You guys see if you can come up with it and then balance it on your own. But again, you need to consider the ion sheets every single time you write these. So calcium carbonate, oopsie, it says is produced. So if calcium carbonate is produced, that's a product. That's the correct formula for calcium carbonate. From a reaction between calcium chloride, that's the correct formula for calcium chloride, and lithium carbonate. This is the correct formula for lithium carbonate. It says the other product is lithium chloride. So you should have gotten that. Now I have not balanced it, but I believe actually, there's the answer there. Okay, that's correct. Okay, so try some of those. All right, I'm going to stop there and produce another video on predicting products. Okay, so if you have any questions, email me.